Right. Hello, everyone. We've decided to make these videos on how to run workstations jobs on Rescale. We're going to show one of the tutorials right now. This specifically will be on workstations and how to use Anaconda inside of a workstation. I'd like to start off by saying that I'm Ahmed Torky, Civil Engineering Department at the British University in Egypt. I have with me here Sherif Samy Sorour. He's from the Mechanical Engineering Department. Say hi, Sherif.
Hi everyone.
We're gonna have these sessions together, like to show a few steps and discuss like portions of the workstation together, ask each other questions, and as much as possible, like provide you with a quick and brief steps on how to kickstart your work on Rescale. I would like to thank Lauren Smiley and James Imrie from Rescale for their support. They've put in a lot of effort with us at the British University in Egypt to get this cloud computing service started. And we're part of the engineering cloud supercomputing division. So please, whenever possible, let us know what your questions are. For a workstation, we usually start a workstation from here. So new workstation, create a new workstation. And then we have a couple of software here. Probably for me, the interesting ones are anything to do with Anaconda, NVIDIA, sometimes ANSYS. How about you, Sharif? Which software do you think is interesting?
I think Abacus as a finite element software, MATLAB as well. These are mainly commonly used in our department in mechanical engineering. This is, of course, besides ANSYS.
Oh, I see. I think for us as well, Abacus might be interesting, and Flow3D. It depends on specializations in the department. And I think if I have a look over here, just let me click everything, open everything. I think some people would be delighted by MATLAB as well. It's available over here. I think there is one of the tabs that allow you to like get visualization software like ParaView, and another one that allows you to bring your own software. But today we're going to be focusing on how to use Anaconda. So most likely Anaconda will be this version, Miniconda Interactive. If you're going to be searching for it, just type Miniconda and go to the Ubuntu version. And also we're going to add NGC catalog interactive workflow. This helps us handle our CUDA drivers. Sharif, have you used Anaconda or any like Jupyter Notebook or Spider?
Yeah, I have an experience with the Jupyter Notebook through Anaconda environment. And I have previous experience with Spider earlier when I was learning about machine learning.
Oh, that's great. I think people who are gonna be or gonna use Rescale for their deep learning or for their large language training their large language models, they'll be using either Miniconda like environment or maybe Spider if they're more interested in this GUI. So for now, we're gonna just keep it to these two, Miniconda Interactive and NGC Interactive. And there we're gonna have to use pick our hardware. So we would recommend not using the general purpose available workstations, going immediately to the GPU ones. And I found Grossler-1 to be the most efficient. Efficient in terms of pricing and number of GPUs. So over here, I go back to the top here and I decrease my wall time to 4 hours, which is probably sufficient to train one of my models. And please have a look at the number of cores and GPUs available. Have you tried GPU ones before, Sharif?
No, that would be my first time with you.
You're all right, so you're in luck. You're
So
gonna see
yeah.
how to use a GPU workstation here. I've
Okay.
tried other ones
Uh,
like Celestine and Aquamarine. They have stronger GPUs like V100 and A100. This one has A10. Probably A100 is the most impressive one, but are you willing to pay $40 or the amount of GPUs are extreme a bit per hour? So yeah, I'm not sure if this is the actual pricing right now or because I'm using a workstation already. It's a huge price, but it's definitely worth it if you need to run something strong.
right.
Uh,
So okay, sorry for interruption, but regarding the wall time, if I exceeded that, it will auto suspend, correct? So I need to have a good estimation at the beginning
yes.
about my okay.
So it's best to have a quick look at the start at how many for one training iteration of your model with the number of epochs and the amount of parameters. How much time do you usually need? So if you need like 2 hours, I would recommend maybe 4 hours, like having buffer 1 hour at the start and 1 hour at the end. Maybe it would be even safer to go to 12 hours and then suspending or closing your workstation once you're done. If you're not sure how many hours it would take to train your model on a GPU workstation. Um,
Okay, and
yeah,
in case if I wasn't lucky enough to be able to scale my problem, for instance, if I used 4 GPUs and I thought that 1 hour would be enough, then when I'm using higher number of GPUs, because of the scaling cannot be linear, sometimes it's non-linear, I can
yes,
later on increase the wall time
yes,
later on, correct?
yes,
So I
that's
don't have to
correct.
worry.
Yeah.
Yes, but it requires me to follow up with my workstation in case if I'm not sure in my final model regarding the wall time.
Yes, that's exactly correct. So we're gonna have a look at that, how to modify the wall time while we're running, just to
Okay,
avoid trouble. And over here, we're gonna, in this last part, we're gonna upload our attachments. You can upload from the computer or from the storage system. I have this data set from, I think this one is from RoboFlow. RoboFlow, it handles images quite efficiently,
okay,
and it prepares it for computer vision models like YOLOv5 and YOLOv8. I'm going to select it for now. And next step is I just need to click next here, choose the project that I'm working on right now if we're using project um, credits, and then press submit. For now, I'm not going to run this one because I have one already dedicated for this session. It's this one. Let's have a look at it inside here. So you can see my setup is ready quite similarly, and its status right now is that it's been running for a while to um, initiate this tutorial. And if we go back one step here, you can see, as you've said, I only have 1 hour remaining on this runtime. I can increase it an hour further over here or decrease it. And I think it calculates the time at per minute, not per hour. So if we were able to complete this workstation early, we can immediately stop or force stop this workstation, this open workstation from up here. I'll connect immediately right now. So I'm going to enter this workstation, and you can see here my clear Ubuntu workstation. You start off by pressing activities here and going to the terminal. So this terminal is going to help you download and install and handle your environments. We start off by, I have a list here of everything we have to do. So after opening the terminal, we need to create our environment. So this is it over here. We are going to paste it with a right click over here. And this tells me that I'm already inside of an environment called UEnv. I'm going to create a new environment. I'm going to name it AI capital ENV. and it's going to be working on Python, an older version, which is 3.9, and it's going to also download other environments that usually come with Anaconda. All right, this usually doesn't take a lot of time. Depends on your, unfortunately, sometimes it depends on your internet. So I'm okay with downloading all of the above environments. I agree to it with the Y enter. And then it's going to be almost done over here. So this is how we start. We create a new environment after we've entered into the terminal. As I can see here, it's quite fast. It should be showing like bars over here of executing this environment. It differs from maybe one operating system to another, but once it's done here, it's going to recommend for you to activate the environment using this line over here, this command. So I'm going to paste it over here, and as you can see, we're inside of the environment already. So why are we doing this? Because we don't want to change any base or default environments. We want to play around in a new environment without destroying like Miniconda or Anaconda that's been installed already. So once we're inside of the environment, I usually use this command over here. It's called xgd open the desktop. So it opens for you the folder. As you can see here, this is now the workspace I'm working in. And over here, the data I've uploaded has been immediately extracted from this file. As you can see here, it's in files. This one exactly. It's been unzipped immediately into my work shared folder. And as you can see here, it includes, this is not required, it includes test train valid data.yaml. This all is inside of the zip file. Yeah, I can see you have a question.
Okay, so it doesn't matter the format of my uploaded files. Either can be a zip file, or if I combine them in Excel sheet, for example.
Yes.
Right?
Yeah,
In both cases, it will be extracted.
Yes,
Okay.
it will be extracted into the folders. You won't have to go through the hassle of unzipping it over here or extracting it over here. Yes. So the next step is installing PyTorch. We're going to be using PyTorch to do a computer vision example here. So these are the 3 typical steps to install PyTorch and start working with a model called YOLOv5. YOLOv5 is quite efficient at predicting objects in an image, segmenting images. It's YOLOv5 and YOLOv8 are now the state of the art for computer vision deep learning. We're going to be using it to detect objects in an image and classifying them. So since I've already installed it before, it's using wheels or downloads that are already cached. Other people will find that there will be bars over here claiming that that you're downloading the wheels. So I've done this beforehand to make this step a little quicker. This usually takes like 2 to 3, 4 minutes extra. So now we've downloaded everything related to PyTorch. And now we're going to download the YOLOv5 provided by Ultralytics. They're a third-party company, and they've been creating and developing YOLOv5, YOLOv7, YOLOv8. So this is the next step, installing Ultralytics YOLOv5. There is no escaping these ports. So once you're inside of the environment, you'll have to install these libraries. And then the next step is to clone the YOLOv5 from GitHub, clone the YOLOv5 folder. I'm going to paste this over here, git clone. and now it's ready. It should appear over here. So when you head outside to the desktop over here, you'll find that this has just been downloaded right now, YOLOv5. We're gonna have to transfer our folders to YOLOv5 because we're gonna be using the YOLOv5 folder. So the data, such as training data, test data, validation data, needs to be inside of here, along with the data.yaml that calls these folders. So if we have a look over here for the YOLOv5 format, you have the images over here and you have the labels over here. You're gonna have to have all these three folders to run training detection using YOLOv5. One extra step we need to take care of is handling the paths in data.yaml. So let's copy this path. Oh, I've made a mistake here.
Okay.
Let's go off a level and go back. So Control C. And for the people who are not sure about Ubuntu, it's not so difficult. On the level we've been working right now, it's quite straightforward. As you can see here, we need to provide the paths. So I'm gonna add the exact paths over here and Control S and close this. Now almost everything is ready. We need to go to this main YOLOv5 folder and start training. So what I need to do now is cd change directory to YOLOv5. We're inside of the YOLOv5 directory right now. And next step is training. We have this long training command over here, or where you say python train.py. You'll find the data in data.yaml. The weights grab YOLOv5 Nano Edition. The image sizes are 640 by 640. The training is batch size is 20, and training epochs are just 5 epochs. So I'm gonna paste this over here and run it. We might run into trouble here. Let's see if that occurs, because with this Ubuntu version, it gets disappointed by specific up-to-date YOLOv5 and PyTorch versions. So that's why over here we have a specific version that works very well with Ubuntu or Linux operating systems. And as you can see here, the first epoch has already started. It's using 2.35 of the GPU memory currently. And it's quite fast. It's it takes 27 seconds to train one epoch. Usually on the CPU, this takes maybe, let's say, between an hour and 2 hours for just one epoch. So
Okay.
yeah, down from 1 hour for one epoch to 27 seconds. The first iteration epoch usually takes longer than the other epochs. It's not true over here, but anyways, 27 seconds is quite fast. We'll have a look at other things at the top over here. Please ignore these future warnings. It doesn't affect your work. If we have a look over here, we have the Python version that we're working with, the Torch version we're working with, the CUDA version 11.7, and it tells me right now that I'm working on NVIDIA A10, and it's gonna be this version of NVIDIA model has I think around 22 gigabytes of RAM, which is excellent. And this version of the YOLOv5 is Nano. When you head to bigger versions of YOLOv5, it's going to require more GPU memory, but most likely it's not going to exceed 22 gigabytes. And yeah, right now we are here at the last epoch. Do you have any questions?
No, it's going great.
That's I'm glad to hear that. It's right now working in runs/trains/exp. So if we go to runs, train, exp, it's working over here right now. Once it's done, as you can see, it loads the predictions over here, and it provides the best model for you in best.pt. So there's a difference between best.pt and last.pt. Best is the best precision or average precision values it was able to reach. Last is the last epoch. So maybe if you have 200 epochs, the best is maybe at around 180 epochs, while this model is at the very last epoch at 200 epochs. And what you also get here is the after 5 epochs it took how many hours, and for each of the 5 classes of this classification problem we were able to get the precision recall and the MAP50 and MAP1595. As you can see here, we were only able to get 14.7%. Maybe leaving this to 1,000 epochs will be more efficient. And over here, you can have a look at other, like, what can I say here? Other figures that are exported with YOLOv5. One of the most important ones are over here, which are the training epochs. So the training epochs against validation box loss, object loss. You can have over here class loss and other metrics such as improving precision. Okay, so I think this is really satisfactory so far. We can have a look at detection as well. So we've now only been working on training and the train and let's have a look outside here. The train and validation dataset. Let's have a look at the test dataset, what occurs with it. So I have here Python detect ready. Detect works on the test dataset. I need to change a few things over here. So I need to find the best.pt. So the best one is probably right now in runs, train, XP, weights, this one. So I copy this and I go to best.pt and replace it. See, it's ready here. Now it's going to ask me for where the images are that I need to test on. That's my model. So go all the way up here, back to the data folder and test. They're inside of here. We're going to make use of them all and paste over here. Let's hope this works. I haven't tested the detect before. So it's going to use the newly created best model. And it detected all 32 images. And this over here, it tells you how long it took for each image to be detected. And this should be exported over here, runs detect, exp, and you should see the detections over here. It's not so good because we've only been working on 5 epochs, so you shouldn't be seeing bounding boxes over here. If we have a look at this, we should be getting more bounding boxes for each route. But right now it's not working efficiently because simply the number of epochs are not sufficient. I usually use 1,000 epochs. So what do you think, Sherif? We're gonna try YOLOv8, but would love to hear your questions.
No, I think your explanation was clear and informative. So I think we can move on to the second part.
The second part. That's great. Okay. So over here, I'm gonna go back to the main folder, change directory to the main folder. And then I'm gonna try YOLOv8 as well, just really quickly. So I have here YOLOv8 ready. Let me see, did I not forget to drop it over here? So I might have forgotten to bring YOLOv8 with me. Let me see if I have it in the past before deleting the past environments. So it's not this one. I believe it's going to be this one, Ultralytics, git clone Ultralytics, and then another time Ultralytics. I think because it's the latest version of, just a second please. All right, so I'm going to take a copy of this on the side to show the audience later. So I'm going to drop it over here. Yeah, and it should be just before training with YOLOv8, which is this line. Anyways, let's click enter on this, and you'll find a new folder over here. It should be Ultralytics, yeah, this one. Head into another Analytics folder and go to the data, and we should drop our data set over here. All right, so let's do that again. Back to work, shared, get all of these back here, Ultralytics, that, drop it over here. Okay, get the path, go back to data.yaml. It's a new version, so let's drop the exact path over here in the file, save it, and close, and that's it. So now we should be working inside of this directory. So Control C over here, cd, change to the new Ultralytics directory. I think we need to delete one path, and that's it. All right, so the next step is, once we're inside this directory, we have YOLOv8 ready. Let's try to train now. So it's quite different from YOLOv5. You say YOLO train model, choose YOLOv8 nano, tell it where the data YAML file is. We're gonna run it for 5 epochs as well, and inform it of the image size. Control C, Control V over here, and let's run this. Let's hope it works. All right, so it's working. The epochs are gonna start soon. All right, and as you can see, it's maybe a little faster than YOLOv5. I'm confused to why that's true, because I'm usually aware that YOLOv8 has more parameters than YOLOv5. Maybe it's efficiently implemented on training on the GPU. So parallel computing with YOLOv8 is maybe much easier than YOLOv5. So we're gonna just wait for 5 epochs. And in the meantime, if we're running out of time, we can go back to the workstation here and increase the wall time iteratively as we see best fits. Oh, by the way, the Sherif as well, they send us an email. Is that correct? 30 minutes or 15 minutes beforehand.
Yes, that's correct. They usually send us a warning message when we approach our wall time threshold that we already specified. So this is really a good thing to be notified to update the wall time without being checking from time to time how
Yes.
many wall time I have left.
Yes, I agree with that. So have your mobile or have your email ready on the site giving you notifications. It's going to be very useful.
Yeah,
Thank you.
besides, you can log in to Rescale using your mobile, so you can increase the wall time through your mobile as well. So
Oh,
it's really easy and fast. So
yeah.
yeah,
I think I'll start using that very soon when I have more resources to run on the cloud. That's actually going to be very useful.
yeah.
Thank you for sharing that. And as you can see here, for all classes and each individual class, we also get the precision, recall, and other metrics. It's done for now. We head back to runs. Same deal, go to train, and you'll see here your confusion matrix and other figures. Important of which, again, is the metrics changing over each epoch. And it seems like maybe YOLOv8 is a more intuitive choice for this dataset, but still a good idea to try both. So usually we go to work over here, shared, and this is what is going to be extracted from the workstation once we're done. So these are input files. We're not interested in having them exported with us back to our storage system. So I'm going to shift delete these, permanently delete them. All right. Now I'm sure that I'm not going to have excessive data or folders being transferred. Over here in YOLOv5 in runs, we have these 2 folders. I'm going to take them, Control C, go back to the work over here, shared, and paste them over here. We can add them to a zip file, or archive them. Okay, I'm gonna call it YOLOv5 because this was specifically dedicated for YOLOv5. All right, I don't need these two anymore. Now I'm good to go with YOLOv5. I need also YOLOv8 results. Where are the runs? Over here. So I can go all the way down to this. Like I can just click this one, and this is the folder I need. And I'd like to thank James again for supporting us in making this tutorial. We've run into a few hiccups at the start when designing this tutorial. This has helped out a lot. His quick and informative help has helped out a lot. So I'm not sure why YOLOv5.7z appears with us. We only need this one. Can I choose all of this? Maybe without picking any of them? Or would it be better to highlight? It's not working. Let's see what's going on here. Create archive. Create. All files, okay. Not sure what's going on here, but okay. These are fine. Okay, tell you what, I'll go back to Ultralytics, runs, zip, create an archive for this one. I'm surprised that it's not working. What's up with that? Oh, here it is. So I don't need this one anymore. Rename YOLOv8. Okay, I think we're ready to leave this workstation. I would say delete these two as well. No need to keep them. And now we're good to go. It's in work shared, double check. Okay, we're done. Over here, never mind that. We can Conda deactivate. We're outside of the environment now. We can close the terminal. I'm not sure if we can close from here immediately. Disconnect. I'm not sure this closes the workstation. You'll have to close this tab. Yeah.
Yes, so we may need to check that again from
from inside the
platform.
Yes. And as you can see here, at the very start, we've made our workstation. We've started the server. We're right now inside of the running server, and next step is to press the button stop. Once stopped, our workstation cannot be restarted. Runtime files will be saved. All right, we're good to go. So it will start stopping. It will start stopping the workstation right now, or terminating it, and files will start appearing over here. But it might take like a few more minutes to transfer the files to the storage system. I don't think they'll appear right now. It will take them time to appear. And if we're done with this input file, we should be deleting it as well.
So it's a really good practice to delete the files after I download them, so that I will
Yes.
not crowd my files folder in Rescale
Yes.
with so many files types, right?
I agree with you on that. Yeah. So all input files or output files will appear over here. It's best to get rid of them once you've made sure that you've downloaded the output files specifically. So it's stopping right now. No need to force stop it. Things are going well. You should be getting an
Force
email
stop
as
it.
well. Yeah.
Okay. I mean, force stopping will stop the workstation, and you may lose your files. So
Yes.
we don't need to refer to this option unless I don't want to save my files for some reason.
Yes. It's likely that things will go wrong. So it's best to take care you close the station correctly. So I wonder if from uploading patch of files, that means the files will start appearing here. Oh, it's done. They've appeared.
Okay.
And that's it. That's
Okay.
our training session for today, tutorial for
Okay.
today. As you can see here,
Thanks a
it's
lot
done. Yes,
for. No, thank you a lot for your informative demonstration
I'm
on how to
happy.
set up the workstation.
Yeah, I'm happy you're with me and it was successful. We can have a look at the archived workstations over here. So one thing to note, once the workstation is done, you should click it and archive it. That means you can get rid of any input and output files and unlink everything over here. So as after 3 days, all your files will be deleted automatically. I think next tutorial, Engineer Sherif will be talking to us about working on jobs. Specifically, what would you like to talk about, Sherif?
About how to run Abacus models uh, through Rescale as jobs, and how to perform sequential analysis using Abacus in Rescale as well.
That's exciting, and I think it's way better to be using jobs if the system is laid out for you to be using like hefty software like Abacus on service level instead of operating system level.
Yeah, that's your software that provides an input file. It's much more easier to run it as a job, and much more cheaper in the cost-wise than running them through Workstation.
I
So
see.
Abacus is one of these software, and we will discuss next time how to run a job in our series.
All right, looking forward to it.
So see you next time.
Yes, see you everyone. Bye bye.